Hello everyone. So we're going to start with empirical rule. The empirical rule says that if your x is distributed normally with the mean mu and standard deviation sigma, then these are three important observations. It says that 68.27% of the observations are within one standard deviation of the mean. Okay, remember this was the normal curve and this is the notation for the normal distribution. So when I say that 68.27% of the observations are within one standard deviation, so we're basically talking of here. Remember, the mean is where the mound is, okay? And that's where 50% is dividing the whole observations. But we say if you go to either one standard deviation of either side of the mean, then here we have 68.27% of the observations. So basically this is what we are talking about. Remember, it is above the x-axis here, so you're not going to look at things below the x here. Okay, now let's look at the next one. It says if observations are within two standard deviations of the mean. So let's take a different color here. So we are here two standard deviations. So we're basically this mu minus 2 sigma, that's two standard deviations of the mean, or mu plus 2 sigma. So the ones in red, guys, are basically talking of that 95.45% of the observations of your experiment lie within two standard deviations of the mean. And you have to be very careful is that when you have a normal distribution, only then we can talk of the empirical rule. And let's the last one is that if you are within three standard deviations of this mean, then your 99.73% of the observations lie within it. So you're basically very close here. So that's almost touching the exam. So here, basically, if you have three standard deviations, so all the green part, guys, which goes beyond the red here, that, guys, is including 99.73% of your observations. Okay, so that's our empirical rule. Let's take an example. Now, suppose x has a normal distribution with mean 50 and a standard deviation of 6. Remember the notation? X is 50 and 6. And also always I tell you whenever we write it, let's quickly make a little bell-shaped curve and see what happens. So when we make a bell-shaped curve, I'm just going to go a little, okay, here. I'm going to take a different color where I can see all this. So here's my bell-shaped curve, guys. Okay. Now mound here is 50 and we are going to go 6 units on either side. If you go on the right, we add, it's 56. Then what are we going to get? 62, 68. And now if you go on the left hand side of this mean, we're going to be subtracting 6 every time we go. 44, that's one standard deviations. And then we go another, we are going to get 38. And the last one, when 3 standard deviations on the left, is 32. So basically, we have already got our answers. Now, about 68% of the x values lie between, remember, when we go one standard deviation. Here we are talking about one standard deviation. So they lie between 44 and 56. Now, about 95% of the x values lie between two standard deviations. That means the values are here. Here is my values we're looking at. These are the values for my two standard deviations. It's going to be 38 and 62. The last one, about 99.7% of the x values lie between three standard deviations. So that means we are basically going till the very end. So we're like this, 32 on the left and 68 on the right. So it's 32 and 68. Okay, now let's look at an example. It says the normal distribution for woman's height, apostrophe is wrong, just right here, in North America has a mean of 65 inches and a standard deviation of 3.5 inches. Most major airlines have a height requirement for a flight attendant, although some exceptions are made, but the minimum height requirement is 62 inches. So the question is, what proportion of adult females in North America are not tall enough to be a flight attendant? So proportion, remember, is related to probabilities. Okay, so when you see the word probability, proportion, percentages, you're talking of probabilities here. So let's read down and see what is given to us, and then we go ahead and solve the problem. The first line sentence says, normal distribution of woman's height has a mean of 65 standard deviation. So we can say let X be, it's a random variable, be the normal, it's the height, because we're looking at the height requirements for flight attendants. It's the height requirements of the flight attendants. Okay, and it says the flight attendants, and they're looking at the woman's height, so it's the the height requirements of flight attendants, or the woman's height in North America. What are we given? We're given that this random variable, X, is a random variable, and it has a normal distribution. Remember, the moment you see the word normal, you write it in the notation. X has a normal distribution. You need the mean, you need the standard deviation. So that's what, 65 and 3.5. So what is the next step we do? Quickly, go ahead, make that little bell-shaped curve and write down the terms given to us. Where the mound is, you simply write down 65. Then after that, we add 3.5 on the right. So we're going to get what? 68.5. Then we are going to get 72 and then 75.5. Okay, now let's go on the other left hand side. Subtract 3.5. You're going to get 61, I think 62.5 if I'm right. Yeah. Oh, sorry. 61.5. So 0.5 is 62 and 3. Yeah, that's right, 61.5. Go back more is 58, and one more back, 3.5, you are getting 54.5. So I'll just write this here, 54.5. Okay, so if you've written down that normal distribution, made a little sketch of a normal curve here. Now let's read the problem again. It says most major airlines have a height requirement. Although exceptions are made, but the minimum height is 62. So if you want to be a flight attendant, guys, keep in mind you need to be at least 62 in North America. Now the question is, what proportion of adult females are not tall enough to be a flight attendant? So in other words, the females adult who are having a height less than 62 cannot be a part of it. So that's what they're asking. So what basically the question is saying, what is the probability that X is strictly less than 62? Now we all know, we have been doing our formulas, normal CDF, guys, and it's -999, then the upper limit is 62, and then we write down the mean, which is 65, and 3.5. That's the standard deviation. What are we going to do? Get our calculators, guys. Okay, once again, say second and var, so you get normal CDF. Use the cursor, press enter, and now remember you're having -999, that's the lower end, but the upper limit is 62. So take your cursor over here. Now remember, this minus, guys, is this minus. Just always remember. Otherwise, you're going to have issues. 62. Now remember, this one has the mean 65 and the standard deviation is 3.5. Now take your cursor down and then just press enter and enter. What are we getting? 0.19568. Okay, let's write down that answer. So the answer is 0.19568. So roughly it means that 20% of the adult females in North America are not tall enough to be a flight attendant. That's what it simply means. Okay, now let's look at one more example here. Okay, here we are talking about monthly rental rates. So this example is in January of 2011, according to my newplace.com, the average monthly rental rate. So the average monthly rental rate for one-bedroom apartment in Ann Arbor, Michigan was $796. Now the average means, guys, the mean. Now suppose the rental rates across all one-bedroom apartments in Ann Arbor follow approximately a normal distribution. Okay, so we're saying that the rental rates are having an approximate normal distribution with a standard deviation of $150. Okay, so then the question is, find the approximate proportion means probabilities once again, of one-bedroom apartments for which the rental rate is at least $8,000 a month. Before we start the problem, guys, let's see what is the variable we are talking about, and as the variable has a normal distribution, let's write down the notation and make that normal curve. Okay, the first thing is, what is this random variable? The random variable here, remember, is monthly rental rates. It's a monthly rental rates across all, so I'm just going to make the line, I'm not going to write it down, guys. It's a monthly rental rates across all one-bedroom apartments in Ann Arbor. So, just fill the gaps from here. Okay, now this is a random variable because the monthly rental rates keep on changing. It's uncertain what's going to be as time goes by. So that means we are going to have a random variable. So and it's a random variable, it will have a distribution, and this distribution which is given us to be is a normal distribution. So that means this x has a normal distribution. Now remember, two parameters are needed for a normal distribution. One is the mean. Mean is given by the average, which is 796, and that's by default we always write first. And the second one, a parameter for this normal distribution, is the standard deviation, which is given us to be 150. Okay, so we have written down our notation. What is the next thing we do, guys? We basically make a little bell-shaped curve, write down the values. Okay, let's write down these values, guys. This is 796. We add 150 to it. What are we going to get? We are going to get 946. And again, 150 we add, we get 1096. And one more 150 we add, we get 1246. Now this is adding as we go on the right. And as we go to the left, we subtract. Okay, so this bigger one is the mean, remember. That's your mean. Now let's go on the left. You subtract 150, you get 646. Subtract another 150, you get 496. Another 150, guys, and you get 346. Okay, too close. Let me just... okay, Okay, oh God, it's too close. Do you see that here? So let me just write them nicely. They're not basically kind of meshing with each other. 496 and this is 346. Yeah, now I'm happy. Okay, guys. Now here's it. The question is, what is the proportion, approximate, of one-bedroom apartments for which the rental rate, remember X is representing monthly rental rates here, is at least. At least means minimum. That means it is at least 1,000, somewhere here, and more than that. So that means the probability X is greater than equal to 1,000. Now we already know the formula here. We are going to have normal CDF. Then we're going to write the minimum is 1,000. And now I'm going to show you something over here. So if I write 999, and you will notice because we're so used to habitually writing 999. And remember, this number is less than 1,000. So it's going to give us a wrong answer. So I will definitely, because remember, this is the lower limit, the upper limit has to be greater than value. So I definitely should put one more 9. Don't put 3 9s. It's going to be a big problem if you put 3 9s. Because when you put 3 9s, you're going to get a negative answer. And remember, this is the lower limit, this is the upper limit. So I'm going to show you the little graph here. So when you have this as your 1,000, okay, this is your 1,000, guys. So your values are greater than 1,000. So definitely the upper limit can never be 999. It has to be more than 1. It has to be more than 1,000 at least. So to be on the safer ground, let's write 4 times 9. Because remember, probabilities are always positive. They lie between 0 and 1. Okay, so now that's taken care of. Let's write down what's the mean, 796. And what is our standard deviation, 150. Okay, let's plug it over here and get our calculators. Guys, take your calculators out. Okay, second, bars. Then to the number 2. Now remember, the minimum is 1,000, okay? So you have to write down 100 and upper limit, that means it is definitely more than 1,000, has to be 999. One more 9, guys. And this is 796 and the sigma is 150. So take the cursor one more down, paste, and then you get that's blinking, enter and enter. What do we get? 0.08691. Okay, let's write that down. So the answer here is 0.0861. Okay. Continuing with that example, guys. The same example. Now here, it's the same. We are having a 1-bedroom apartment, but now we want to find the approximate, the proportion when the rental rate is less than 500. Okay, so here's the probability. X is strictly less than or even less than equal to, it's fine. When you do that, what does that mean? Normal CDF. Now we're going to have negative 999. You put 500, that's the upper limit, and negative is always written down here. And I'm using 3 9s, you can use 4 9s, it's good enough, no props. Okay, so then we are going to look at these mean, 796 and 150. Let's see what the calculator gives us, okay? So take your calculators out, guys. Okay, second inverse, then highlight the numbers 2, press enter. Now this one, guys, is negative, and make sure you're putting this negative, very important, negative 999. And then upper limit is 500. And the rest is the same. Just take the cursor to paste and then press enter and enter. What do we get? 0.02422. Okay, let's write that down. So the answer is 0.02422. Okay, the last question says, what is the approximate proportion of one-bedroom apartments for which the rental rate is between 500 and 1,000 a month? So what is the formula? Probability 500 less than x less than 1,000. Once again, what are we going to write it as? Normal CDF. Now remember, the lower limit is 500, the upper is 1,000, and then we just basically copy the mean and the standard deviation. 796, 150, and we go to our calculators to do the answer. Okay, second or normal CDF, enter. Now this is going to be 500, guys. Upper is going to be 1,000. The rest mean and the standard deviation is the same. Take the cursor to the paste. Enter, enter. What do we get? 0.888885. Okay, so we have our answer. So the answer is 0.48 and a 5. Well, in the next session, guys, I'm going to talk about a standard normal distribution and do some examples. Thank you.